Okay, specific heat. Going to define specific heat as the change in energy required to increase a unit mass of a substance by unit temperature. In other words, number of joules per kilogram per Kelvin or Celsius. Doesn't matter at this stage. And we are going to use a substance of known specific heat, water, in order to find the specific heat of another substance, iron. So we have water at a high temperature, a hot temperature, TH, into which we lower our sample. And heat will flow from the hot water to the sample, and eventually the sample temperature stabilizes to TH. So we're going to take our hot sample at TH and introduce it into a known mass of cold water at TC, for T cold. And eventually heat will flow from the hot sample to the cold water, and both will end up at TW, T warm. So for the water, the change in temperature is going to be final temperature minus initial temperature, TW minus TC, T warm minus T cold, and we can find the change in temperature of the water. And the change in energy of the water is going to be specific heat of water, which is about 4200, times the mass of water times the change in temperature of the water. So if we have initial and final temperatures of 25 and 33 Celsius, the change in temperature is going to be 8. Do the multiplication. If we have 20 grams or 0.02 kilograms of water, the change in energy, 4200 times 0.02 times 8, is about 672 joules. Right, for the sample, the iron, we're going to say that the energy gained by the water is the energy lost by the iron. Delta E for iron is minus delta E for the water. So change in temperature of the iron is going to be final temperature, T warm, minus initial temperature, T hot. So in this case, the iron has a change in temperature, let's say from 90 to 33, of minus 57 degrees. It's had a negative change in temperature, it's cooled. So we'll say change in energy of the iron divided by mass of the iron, 50 grams or 0.05 kilograms, times the change in temperature of the iron, minus 672, over 0.05 times minus 57. The minus signs cancel, so we get a change in temperature of iron of about 236 joules per kilogram per Kelvin, which is actually a bit low because it should be about 450. Anyway, that is how you do your calculation.